Hi guys, in this video we're going to talk about our 1.6 notes. That's learning the subtraction rules. So I've done it with a number line, now we're going to learn the rules. So make sure you open your packet to 1.6 and let's get started. Okay, so starting with our I can statement, I can model subtraction using integer chips. Model subtraction with, come on, there we go, integer chips. Okay, let me get my integer chips. Where did they go? Oh, there we are. That's okay. So when we subtract, what is happening? We're taking away something, right? Because if I had 5 apples and Billy took 2, I would subtract that he took them. So we are taking away. A value. So let's represent 6 minus 2 using integer chips. Well, first I'm going to show 6. So I need 6 positive chips. 4, 5, 6. Okay. And I need to take away 2 of the positive ones. So I'm going to cross them off. So we basically took them away, or we crossed them off. Okay, so something was there and then it's not going to be there anymore. Different than addition when we would pair them up and then could take them away because they made 0. Okay, so what about 3 minus negative 2? Well, let me show 3. Are there any negative integer chips I can cross off? No, I can't take any of the red chips away. So take a second and brainstorm, what might we be able to do to be able to take away those 2 negative chips? Pause the video, brainstorm real quick. So if I have values that aren't represented and I want to show that, I'm going to add 0 pairs. I'm going to make him bigger so I can write better. So we're going to add 0 pairs. Right? Because if I'm adding a 0 pair, it's like adding 0 because those 2 can cancel each other out. So I'm going to show my positive 3 first. 1, 2, 3. Then I need to add enough 0 pairs that negative 2 is represented. So here's 1, here's 2. But I know that if I have a positive with it, this is 0. So I'm not changing the expression or the equation. I'm adding 0, but just in a really clever, creative way. So these guys are my 0 pairs. So I added 2 0 pairs. So I would have negative 2 on my board now. Okay. So now I'm going to take away negative 2. So I cross those off, and now I'm going to count the remaining chips. There's 1, 2, 3, 4, 5, and they're all positive. So 3 minus negative 2 is positive 5. Let's do the same thing with this 2 minus negative 2. I'm going to draw 2 positive chips. Okay. And then I need to subtract negative 2, but I don't have any negative 2s to take away. So I'm going to add enough 0 pairs until that is represented. So here's a positive and a negative. They make 0, so I'm not changing my equation. A positive and a negative make 0. Oh, there's 2 negative ones now, so I can stop. I'm going to take away -2, and I'm left with +4. Okay? Last example on this page. So -6 minus 3. I'm going to show -6. 1, 2, 3, 4, 5, 6. I don't have any positive 3's to get rid of, so I'm going to add 0 pairs. There's 1 positive, 1 negative. Here's a +2. Here's a +3. So now I can take away +3. I'm left with -9 because I have 9 negative chips. So -6 minus 3 is -9. So using that concept of adding 0 pairs, I'm going to do that and kind of compare some things. We're going to use integer chips for all of them. So 3 minus -2. I'm going to have 3 positives. Okay. I need to be able to subtract -2. So I'm going to add enough 0 pairs until -2 appears. Okay. Then I'm going to get rid of my -2. And I'm left with 5. Okay. Now I'm going to just do 3 plus 2. So I'm going to show 3 positive integers. I'm going to add 2 positive integers. And that also equals 5. So 3 minus -2 is the same as 3 plus +2. Wonder what's happening. Let's try another one and see if we can kind of figure it out. So 2 minus 7. I need to show +2 first. And then I need to add 0 pairs until I have 7 to take away. So here's 1, 2, 3, 4, 5, 6, 7. So I'm going to take away +7. 1, 2, 3, 4, 5, 6, 7. Okay, oh, but I can still make 0 pairs, so I need to do that. So I'm going to circle a positive with a negative and cross it off, a positive with a negative and cross it off. We're left with 1, 2, 3, 4, 5 that are negative. So 2 minus 7 is -5. Now I'm going to do 2 plus -7, and we'll see what it ends up being. So I'm going to draw 2 positive chips, and then add 7 negative chips. 1, 2, 3, 7. Going to make 0 pairs. Cross them off. Cross them off. You're left with 1, 2, 3, 4, 5 that are negative. So 2 minus 7 and 2 plus -7 end up being the same thing. So what am I seeing? We had 3 minus -2 was the same as 3 plus a +2. We had 2 minus +7. It's the same as 2 plus -7. you seeing here that when I switch the operation, I switch the sign? Let's see if it works for the other one. I switch the operation from subtraction to addition. I switch the sign of the second number. Let me get my paper because I said it a really fancy way. So, similarities between subtraction and addition. To switch from subtraction, oops, we'll start over. I'll make more room. So, addition is the same as, let's say subtraction is the same, I'm sorry guys. Subtraction is the same as addition of the opposite sign. Okay? So like we saw, 2 minus 7 is the same as addition of the opposite sign, so plus negative 7. Okay? So we're going to call it a subtraction trick, a little way to remember how to do it. So it's called keep, change, change. You're going to keep the first value. You're going to change the operation from subtraction to addition, and then you're going to change the sign of the second number, and then you can just follow your addition rules. So for negative 15 minus negative 30, we're going to keep, change, change. So we're going to keep negative 15, change subtraction to addition, change negative 30 to positive 30. And then I can just follow my addition rules. And I don't have to remember this long set of addition and subtraction rules. If I just change it to addition, it makes faster. They are different signs. So we're going to subtract. We're going to take 30 minus 15 is 15. 30 is positive and larger. So my answer is positive 15. Okay? So I kept the first number, negative 15, the same. I changed the operation from subtraction to addition, and I changed the sign of the second number. Okay, let's try it again. I'm going to keep the first number, negative 17. I'm going to change subtraction to addition. Then I'm going to change the positive 30 to a negative 30. Okay. Then I'm going to use my addition rules. Sorry, thinking about subtraction. Use my addition rules. They're the same sign, so I actually add them together. So 17 plus 30. It doesn't like when I write 3's for some reason. There we go. Is 47. They're both negative, so my answer is going to stay negative. So it's negative 47. Right, because you don't want to draw 30 integer chips, 30 zero pairs, okay? Times 2, that would make 60 integer chips to make 0 pairs. Okay, that's a lot of work. So if I can just change it from subtraction to addition, I only have to remember that one set of rules. It also sometimes works, or it also works for addition. Sometimes that might make it easier, right? You can always just check and see. Does that make it easier? Does it not? So we can see 75 plus negative 22. I'm gonna keep the first number, 75. I'm gonna change addition to subtraction. Then I'm gonna change the negative 22 to a positive 22. And it's positive 53. So sometimes you can convert between addition to subtraction the same way. Sometimes that might make it a little easier because that's what you end up doing anyway. They're different signs, so you subtract. Okay, so you keep the first number the same, change the operation, change the sign of the second number. So your 1.6 practice and practice check. Level 1, you are just rewriting them as addition problems. So use keep, change, change to rewrite them. You're not solving anything yet. Level 2, you're going to rewrite them as addition and then model them on a number line. Because this also makes it easier to use a number line. So I don't have to think about which way it goes and back and forth and back and forth. Okay? So level 2, change them to addition, then use a number line. And then level 3, you're gonna change them to addition. You can use the number line if you want or if you don't want, okay? So if you just wanna use your addition rules, go for it. But the number line is there if you need it. Good luck, have fun, see you later.